Root guard protects against attacks that would change your spanning tree design. Let's go talk about this important tool. This video talks about root guard, which in the book I cover in both chapters 9 and 10, concepts in chapter 9, configuration and verification in chapter 10, and this slide lists the headings in chapters 9 and 10, but it's a subset of those highlighted headings here in the book. As a brief aside, root guard gets mentioned in exam topic 25D. 25D is addressed in both chapter 9 and chapter 10, spread around. But in particular in the books, if you want to go find it, there's a smaller heading, if you will, called root guard, and the other one, root guard, in those consecutive chapters if you want to go read that content. So what are we going to do together here? Well, this topic is relatively straightforward. So we'll talk about the concepts, and then we'll talk about how to implement it. Easy peasy, right? All right, let's talk about it. But before we get there, as usual, my promises for those that stick around to the end, I'll tell you what, if anything, you really do need to read from the book. I'll give you one review activity to go along with this video, and then I'll give you a few words about winning this trivia challenge related to spanning tree. There's just so much detail in the output. How do you sift through it for this latest feature, root guard? All right, now let's go get into it. For root guard, we're protecting against an attack or a mistake that would cause the wrong switch to become root. So imagine this. We've got D1 and D2, and they're the ones we want to be root. D1 needs to be root if everybody's up and working. If it fails, we want D2 to be root. A1 and A2 are kind of in the middle. They're the third best in terms of priority for becoming the root, but normally we wouldn't expect that. And then I1 and I2, think of the I for inferior. They are the worst. In fact, they're so bad that we might even give them a worse or higher priority than these switches in the middle to just absolutely make sure they're worse. We just don't want them to be. We want all the traffic to be funneled up toward the root switch D1. Now that's the design point. And we know these switches down here exist. However, there's a possibility someone might still hook up a rogue switch somewhere in the network, or you might make a mistake. And if that happens, what can we do to protect ourselves? And that's where root guard comes in. All right. So I need to give you a few definitions so I can talk through the problem. So there's this idea of a hello BPDU happening during the election process. And when you're having the election for spanning tree, it says, hey, I think the best route is this. And it lists their bridge ID. I think the best route is that. And everybody claims who the best candidate is. And the one with the lowest numeric bridge ID wins, the one with the lowest priority. So this term superior BPDU refers to a BPDU that claims a root bridge ID with a better, that is lower, value than the current root. It's superior to the current root. And an inferior one is one that's worse than the current root. So superior BPDU. So by design, if you go back to our design, if our design is D1 and D2 are our two favorites to be root, and I1 and I2 are our absolute worst choices, we should never have an incoming superior hello BPDU from these lower switches, right? If the switches are following our design. So what this root guard tool protects against is somebody configuring these switches with a lower priority, or plugging in yet another switch down here with a low priority and having an attack or maybe a configuration mistake that sets a very low priority and changing the root switch to be down in this part of the network rather than up here. So to make this work, we don't turn on root guard up on these primary links nearer to the intended root switch, but down on the bottom where we expect only inferior hellos, we would enable root guard. And in particular, we'd enable it on these ports down on switches A1 and A2 that connect down to I1 and I2 because the feature monitors incoming BPDUs. So here are some incoming BPDUs from I1 and I2. Those should be inferior. If they're superior, root guard acts. What does it do? It changes the spanning tree state. So to sum up the rules, it monitors those incoming hellos. If a superior hello is received, it moves the port to a spanning tree broken state, which means no frames in or out. And it also has a substate of root inconsistent, so we know why it's in a broken state. So it's not forwarding, it's not blocking, it's broken. The interface state remains unchanged. It's still connected. So show interfaces status will still show it up, but the spanning tree state is broken. All right. You got to choose wisely based on your design, which is why I started with the design discussion. So it's ports connected to other switches that should never send in to this switch. We should never receive from them a superior hello. Now let's just say they're on switch A1 and A2. That happened, and the port was placed into a broken state. To recover from that state, you got to make those superior BPDUs stop arriving. So you go find who the culprit is and reconfigure them and make sure they don't do that anymore, and then the port will recover automatically because it doesn't get any more superior hellos. The implementation is pretty straightforward. You can only enable it with an interface subcommand. There's no global option. So you get in interface mode, spanning tree guard root enables it. You want to turn it off later? No, spanning tree guard root. See, relatively straightforward. Now, if you want to see the state when there's no problems, that is, there are currently no incoming superior hellos. In that case, you do a show spanning tree interface. Now, if you leave out the VLAN, it shows you the state for all the VLANs. If you include VLAN, it just shows you the state for one of the VLANs. Here, I've limited it to VLAN 9, interface gig 101 without the detail keyword. I see the interface state is forwarding, and I see it's a point-to-point type. That's great. But if I tack on the detail keyword, I see designated forwarding, which matches up to the shorter command above. But I also see that root guard is enabled on the port, confirming the configuration I just saw. All right. So we know it's configured, and we're running along. It might be that way for months and months and months until someone makes an attack or makes a configuration mistake and sends in that superior hello. So after a received BPDU that is superior, so it's a superior BPDU that must arrive. Notice the shorter version of the command. By the way, both boxes show the exact same command as in the previous slide. The state is shown as BKN with an asterisk. So BKN is short for broken. And over on the far right, we also see this qualifier of shorthand for root inconsistent. The detail command spells out those words. It says broken. That's not just a description. It's a spanning tree state. So the port state is broken, and a substate, if you will, is root inconsistent. By the way, the loop guard feature has a loop inconsistent substate and does the same mechanism. And we also get the confirmation that the feature is enabled on the port. Let me clean up a few odds and ends here. Just to reiterate, there's no global config option with root guard, so you've seen all the config. So that's pretty easy. And also, we talk a lot about port fast with these optional STP features. Root guard has nothing to do with port fast. Also, loop guard, another topic, also nothing to do with port fast. For the new CCNA topics in 2024, it was BPDU guard and BPDU filter that could be reasonably applied with port fast. As always, I promise you some extras to help you with the exam. So, this topic comes from chapters 9 and 10, small headings, also labeled root guard. And honestly, you can skip them. The video does a good job of handling all the details. But you could also use that for review. Wait a couple of days, open up the book. It's not long. It's like a page or two in each chapter on root guard. So there you go. You can use it for your advantage. As a review activity, I've got a terminology mind map set up for you. It's definitely an activity. As always, the activities are better if you'll do it sometime. If you know you're only going to do it if you do it right now, do it right now. But it's better for you if you'll kick it out a day or two, and even better if you'll schedule it in your calendar so you don't forget to do it. All right? And so it's a terminology mind map. That means I give you one term to start it. Big shock. The one term is root guard, so you'll make your map based on expanding ideas from the main topic of the video. Last up, how do you get through all the show command output? Well, this one topic isn't too bad, but it's all those related topics that kind of clutter up your mind about what's what. So for root guard, as is common, you can't really see that it's enabled with the command without the detail keyword. That is the show spanning tree interface command. Without the detail keyword does not reveal whether you've configured root guard or not. So you do need the detail keyword to see that it's configured. It's just stated in one line of the output. But to see the failure state, you can see that clearly in both the briefer command output without the detail keyword or the longer command output, because it uses spanning tree state, right? It shows a broken state, and you see that in a lot of spanning tree commands. And just to revisit that, the shorter command that lists the interface, in this VLAN it shows the broken or BKN state. So just be aware of that new abbreviation, if you will, BKN, and what this root inc means. It's not root incorporated, it's root inconsistent. And then it's much easier in the detail output down here because it spells out what the words mean. Thanks for hanging till the end. Much appreciated. Let me know what you think. This one was pretty quick. Hopefully it was clear. Hey, folks that are new, subscribe and click the bell. It works just like every other YouTube channel, but we'd love to have you join in with us. And give me a like if you liked it. That's the best way to tell YouTube to tell more people about my videos. Thanks, y'all. Talk to you.